Okay, here we are again with the 2017 AP number 6. No calculator question. The AP number 3 and AP number 6 are trends now. They've happened in the past 3 tests, so we can assume things like that are going to happen again. Let me just talk about some basic ideas here. So once again, they're going to give us a graph. I'm not sure what they're going to ask us for. But remember, whatever graph they give us, the values of that graph, or whatever the function is, the next one down will be the slopes. The next one up will be the integral. And they've started asking a lot of questions about finding derivatives without giving you an equation. Meaning, they'll give you something like this. Just going here. Nope, I lied. I wrote that down wrong. They'll give you something like this. They'll say g of x over f of x. Now that is a quotient rule, okay? And we know u prime v minus uv prime over v squared. They want you to translate this information from that equation. So u prime would be the derivative of the top, which is g prime, and v would be f of x, minus u, should be g of x, times f prime of x, over f of x squared. The other big one they're doing a lot of lately is a chain rule in a general problem, where you'll see like f of g of x, and we know the chain rule, to take the derivative of a composed function, it's the derivative of the outside first, take the derivative of the outside, so it's f prime g of x times the derivative of the inside, which is g prime of x. And the other little twist to this problem is a lot of times give us things like this, f of 2x, where we have a function on the inside. The derivative of that is f prime, same thing, of 2x times the derivative of the inside, which is 2. So let's see if this problem matches those techniques, which they're going to ask me about. There we go. Zoom. Oh, that's a lot of parts in there. Okay, so we got this one right here, and I'll zoom in a little bit. Go. Done. It says let f of x be a function defined by, so they've given me this f of x function. And then they say let g of x be a differentiable function, means you can take its derivative. The table above lists values of g. Hold on, let me move this down a little bit. There we go. Gives values of g and g of x right there. And then there's another separate graph for h. So there's 3 functions involved here, and they're trying to keep you guessing. This function is h, this function is g, and this function is f. Okay, it says, let h be the graph. Find the slope of the line tangent to the graph of f at x equals pi. Okay, do they want me to find the equation for a tangent line? No, they want me to find the slope of the tangent there, and slope is derivative. Now, we're not dealing with points, we want instantaneous slope, and slope is a derivative. They want me to find f prime of x. So f prime of x is equal to derivative of cosine of x, all right, negative sine of x, sorry, negative sine of 2x, all of that times 2. Plus, I should have written this down below, hold on. Let's bring this right over here. So the derivative of cosine of 2x is negative sine of 2x times derivative of the inside, which is 2, plus derivative of e to the something is e to the something, times the derivative of the part up top, derivative of sine of x is cosine of x. So now they want me to fill in and solve this when x is equal to pi. So this is the first step I would do. I'd write that part down, and I'm going to fill the numbers in, and I always remember, oops, pi is 180, so we'll figure these values out as we go. I'm going to start right over here. Okay, so I know the sine curve looks like this, and I know cosine curve starts up top, goes down below. So first I need the cosine of 180. The cosine of 180 is right here. That's negative 1. And now I need the sine of 180. The sine of 180, 0, 90, 180. The sine of 180 is 0. So this whole thing, gone. So this whole last part is equal to 0. And remember, we don't have a calculator for this, and they know you're going to have to work on that. So it's the sine of 2 pi. And the sine of 2 pi is right here. Okay, I'm going to process this info again just to make sure I'm doing this right. I'm going to do a blue pen to make sure. I've got to find the sine of 2 pi, because I'm filling in pi for there. The sine of 2 pi is 0. So 0 times 2 is going to be 0 for the first part. That part becomes 0. Okay, now I found the cosine of pi is right here on the graph. That's -1. I agree with that. And then the sine of pi, which sine of 180 is 0. E to the 0 is equal to 1. 1 times -1 is equal to -1. So the answer to that is -1. Part B. Part B says, let k be the function defined by k equals h of f of x. Find k prime. So that's what I said with these general rules. I've got to find the derivative of this composed function or chain rule. The derivative of the chain rule is derivative of the outside. Leave the inside alone. Times the derivative of the inside, f prime of x. So I've got to find h prime of f of pi times f prime of pi. Well, I've already found f prime of pi. I found that in the last question, and I found that already to be -1. If you made a mistake in the last one and use that answer here, you will not be penalized for using that answer. So now I need to find f of pi. So I need to take pi and put it into the original equation right here. So that's going to be equal to the cosine of 2 pi plus e to the sine of pi. So once again, here's a sine curve. Here's the cosine curve. So I'm looking for the sine of 180. Sine of 180, 0, 0, 90, 180. The sine of 180 is 0. So e to the 0 is 1. So I've got that for this piece right here. Now I've got to find the cosine of 2 pi. So if I look at my graph here, the cosine of 2 pi is 1. And so that this piece becomes 1. 1 plus 1 is 2. So now I have to find h prime of 2. So I'll go to my graph. H prime of 2. I need the slope at 2. Oof, this is a complex problem, isn't it? I agree. Okay, so the slope at -2 is the slope of whatever that line is. So I'm going to check the slope of this line, which is down 1 over 3. So the slope of that line is -1/3. So I've got -1/3 times -1, and I get an answer of 1/3. Once again, nothing very complicated, but very complex, because they're asking us over and over to change what we're looking at to go to a different part of the problem. Okay, let's take a look at part C. Part C has a new function, m, defined by those two functions right there. Find m prime of 2. So what I see is I see a product rule. This is going to be u. This is going to be v. So it's going to be u prime. Derivative of the first part would be g prime of -2x times -2. V is h of x plus u g of -2x times v prime, which would be h prime of x. So I'm going to fill in the 2 into these values here. It's going to be g prime of -4 times -2 times h of 2 plus g of -4 times h prime of 2. A lot of maneuvering around to get to that problem right there. Okay, let's see what we got. Okay, so I need to find g prime of negative 4. So I'll go to my graph, g prime of negative 4. Okay, so g prime of negative 4 is negative 1. So I'll go fill that in. Times negative 2. Now I need h of 2. That means I'm going to look at the actual graph of h. I'm going to find the value at 2. Okay, so of course I try to mess with you here. See if you can figure out what value that is. They're okay with you estimating it. I'm estimating it at about negative 2/3. That's my guess. If I'm off a little bit, they're okay with it. Negative 2/3. Plus, I need g prime of, I need g of negative 4. So at negative 4, g is 5. Oop, wrong way. And h prime of 2. So I need the slope at 2. And the slope at 2, so this slope, which you already said was negative 1/3. So I can totally leave this answer like this. I do not have to simplify it down. That shows me they have all the parts in there together. I do not have to get it into one number, so we're not going to do so. Those parts are all correct now. Okay, let's take a look at the last part of the problem. Oh, lost my graph. Let's go back to here. Let's erase this. Okay. And the last part says, is there a number C in the closed interval negative 5 to negative 3 such that g prime of negative 4, oh, lots of words, is negative 4? Justify your answer. Okay. So they're asking what the slope of the graph G in the interval negative 5 to 3. Well, let's take a look. What's the slope? Oh, let me zoom out here. What's the slope at negative 5? The slope at negative 5 is negative 3. So at negative 5, g prime is negative 3. And then at negative 3, the slope is 4. Okay? And since g is a differentiable function, which means we can have its derivative, it means that it's nice and smooth. It means that if at this point the slope is negative 3, and at this point the slope is 4, every possible slope between negative 3 and 4 has to exist. Okay? So that means that every value between there has to occur, because the graph will smooth that out, and that's due to the mean value theorem. There has to be a value who meets that interval. Let's not even put that in there. Let's try it without theorems to begin with. So does there have to be a slope of negative 4? Okay, so I think there's been enough in this video for right now. I'm going to hold off on this last part because those are the bonus parts anyway. It always has to do with, if something has to exist, it has to deal with the MVT, the mean value theorem. We'll talk about that tomorrow. So here you have your 2 videos and your questions that are you to work on today and are all due tomorrow class. See you then. Bye-bye.